Well, good afternoon, everyone. Can you hear me? My name is Soroush. I am a computer scientist, and I'm currently a postdoc at the MIT Media Laboratory. And today I'll be talking about a tool I developed for my PhD at MIT for automatically detecting and verifying rumors on Twitter. So fake news has been all over the news recently, but the problem of misinformation spreading on social networks is not new. In fact, when I started working on my PhD thesis a few years ago, this was an issue that was very relevant to me personally because during the Boston Marathon bombing, I was here in Boston, living actually in an MIT dormitory. And for those of you who lived here, remember that there was a lot of uncertainty and misinformation spreading about what was happening before the suspects were actually identified and captured. So kind of motivated by that, this is a few years ago, I wanted to see if there is a way to automatically verify information on Twitter. As I mentioned, the motivation behind that was the Boston Marathon bombing. And the tool I wanted to create, which I call Rumor Gauge, I wanted it to work something like this. You would go on my tool, you would type in an event that's happening right now in real time, let's say Boston Marathon bombing as it was happening. And I wanted my tool to automatically identify various rumors that are being spread about the event on social networks. And not only identify the rumors, but also to give a score of how likely they are to be false or true. So this is a cartoon sketch of what I wanted my tool to look like. You type the event, and over time, it identifies various rumors spreading, and then the color is the veracity of the rumor. So if the system thinks the rumor is true, it colors it green. If it thinks it's false, it colors it red. And I wanted this to be done automatically because I wanted this to be used in real time for many events at once. So you probably don't have the resources to have a team of people constantly monitoring Twitter for rumors, and even if they do identify the rumors, it would take them a lot of time to actually verify the veracity of the rumors. So that's why it was really important for me to do this automatically. So that's what I set out to work on, and I was interested in, you can't really see the text here, but I was really interested in 4 target groups. I wanted my tool to be useful for journalists, for emergency services, financial markets, for financial rumors, and of course, consumers of news. I myself, I was just a consumer of the news during the events of the Boston bombings, and I just wanted something that would let me know whether what I'm reading is true or false. So the talk usually that I give is a little bit more technical, so I'm just going to skip some of the technical parts, but here's how I define a rumor. So I define rumor as an assertion that's originating from one or more sources and spreading on social networks. And an assertion could be true or false. So a rumor could be true or false. And you probably all use Twitter, so you know how it works. But if you don't, here's how it usually works. Some account on Twitter tweets something. One of their followers decides to retweet it. And then this keeps going over time. And then what you have is a cascade of tweets and retweets. So here's a toy example of what a rumor actually looks like on Twitter. It's a few original tweets, a lot of retweets, all referring to the same assertion. Now, let's say this is a cartoon example of a rumor spreading. There is usually going to be at some point in time, let's say this is a rumor about the Boston Marathon bombing, and let's say this is saying that there is a bomb in Harvard Square. That was one of the rumors that was spreading. After some time, there's going to be either police or journalists or verified news personnel who come out with a report that says this rumor is true or false. So this is what I call trusted verification. Now, what I was interested in is to see if there's any kind of signal in the data that exists before the trusted verification, and whether that signal can be used to verify the rumor before a trusted source comes out with a decision. So that's the verification part of my system. And of course, there is the important aspect of detecting the rumors. So my system actually has 2 parts. One part detects the rumors that are being spread about an event. The other one verifies them. I'm going to skip some of these slides, mostly because I don't have time, and also they're a little technical. But I do want to focus on the features that I used for my tool. I know there's going to be a hackathon later on, and for people who are coders and have background in machine learning, this might be something that might be of interest to you. So it turned out that 3 categories of features are really useful in predicting whether something is true or false. One is linguistic features, which is what is actually being said in the tweet. The other one is user features. So if you go to a Twitter account, there's a lot of information you can grab from how many tweets they have, how many retweets they have, who follows them, who do they follow, when did they join Twitter. And then, of course, the most predictive feature is what I call propagation features, which is the shape of the propagation of the rumor. So, for example, is it really bursty in the beginning and then it slows down, or does it have a slow start and then suddenly there's a lot of people talking about it? These different shapes are very informative in terms of whether something is true or false. So I'm just going to skip a few slides for the interest of time, and just give you one example of a diffusion feature and why it might be predictive of whether something is true or false. So let's say this is an example of a tweet and its retweet over time. If you scale the nodes, so each node corresponds to one person retweeting that tweet. If you scale the nodes based on the number of followers that person has, so if the person has a lot of followers, their node is bigger. It turns out that if you count the number of links that go from a small node to a big node over time, and you divide it over all diffusion events, it turns out that that ratio, a very simple ratio, is very predictive of whether news is true or false. So it turns out that true news usually travels upwards in influence. So it starts with less influential people and becomes more and more influential. Whereas false news actually has the other characteristic. And so here's an actual example from the Boston Marathon bombing. So the guy on the left has 19,000 followers. The guy on the right has about 10 times as many followers. So the person on the left was an eyewitness who was there when one of the shootings happened. He took a picture, and then it immediately got picked up by influential people. And that turned out to be a true rumor. But this is just an example of kind of an upward diffusion in influence. And there is a very simple psychological reason for it. If you're someone with a lot of followers and have a lot of influence on Twitter, you're not going to risk your reputation and retweet information from someone who no one knows about unless you have some idea that this is true, right? So that's why the diffusion from low to high is it's very predictive. And just to give you kind of the mathematical version of it, if you have two different types of rumors spreading, and here's what the plots look like. Not only is the diffusion from high to low is important, but also the kind of the overall depth of the diffusion tree is also super important. So false news tends to go much deeper, like the one you see on the right. So both graphs on the left and right both have the same number of nodes, which means that they were retweeted the same number of times. But the one on the right went much deeper in the follower network, and that usually actually points to rumor to be false. So these are just two example features. My tool uses 27 total features to predict the veracity of rumors, and I just want to give you kind of two examples of what you could potentially do automatically. Here's how my system performed. So what I did here is I think you should just pay attention to the black line, which is the overall performance of my system. And this is a very simple graph. It shows the accuracy of my system on the y-axis and the latency on the x-axis. So at x equals 0, so this is with all the rumors being superimposed on top of each other. So you can think of rumors starting at x equals 0, and at x equals 100, that's when the rumors were verified by a trusted source. And you can see that looking at previous, so I tested my system on many different events, on Ebola, there were a lot of rumors about that, on Boston Marathon bombings, the riots in Ferguson, just many different events. And you can see that overall, my system, way before any kind of trusted verification by a trusted source, you can see my system can predict the accuracy or the veracity fairly accurately. I mean, it never reaches 100%, but at around, for example, the 75% mark, you can see is that 70% accuracy. So depending on how urgent the matter is, you could decide to trust the system earlier on, or maybe wait for more information to come in when the system is more sure. But overall, you get a pretty good idea of whether something is true or false before any trusted verification. And what the other lines here show, the three different types of features that I talked about, the propagation features, the user features, and the linguistic features, it just shows how much they contribute to the model. And it's interesting that the propagation and user features, they're really helpful in the beginning, but they kind of plateau. They don't really help much after a while, whereas the propagation features, which is the shape of the diffusion that I explained, starts really helping you out later on when there's more information and you can really. So again, it's not 100% accurate, but it works pretty well. Here's two rumors that I ran through my system just as an example for you. So there was a rumor about a Nigerian nurse having fled quarantine. This is a rumor about Ebola, and it spread on Twitter, like most rumors do. So I ran this through my system as if it was happening in real time. Oh, and the rumor was actually true. It was shown to be true a few hours later that the nurse had actually fled quarantine. And I ran it through my system. This is the output of my system. And you can see it took 9 hours for the news to come out that it was true. But so let me just explain what the y-axis here. So the y-axis here goes from -1 to 1. If my system thinks something is 100% true, it will give it a score of 1. If it thinks it's 100% untrue, it will give it a score of -1. And you can see that pretty much like about 4 hours in, my system was fairly confident that this is a true rumor, right? So before any news source came out and said this is true or false. And here's another example of a rumor spreading. This is about Officer Wilson and the shooting in Ferguson. And again, that spread on Twitter. It was shown to be false about a day and a half later. And run it through my system. It took 1.8 days for sources to come out and say it was false, but my system about a day in was fairly sure that it was false. I showed you two examples where my system works pretty well, of course. In some cases, it doesn't work so well. But as I mentioned earlier, it's accurate in about 75% of the cases. So depending on how urgent it is, the rumors you're trying to address and how much resources you have, it might be a good way to at least prioritize which rumors to address first, for example. And I think that's it. Thank you.